This is Shakil Ahmed. In this video, I would like to discuss prediction problem using simple linear regression. Linear regression is used to model a continuous variable when the dependent variable is on continuous scale following a normal distribution and predict the value of the y when for a given value of x. This is the basic machine learning method where we train a model. We train a linear regression model. Linear means y is equal to alpha plus beta x, and then we predict the value of y. So we will discuss. We already discussed how we can estimate a parameter, a, a, a regression model using Python for the data set of average glucose level and age of the respondents. So the average glucose level depends on age. So when we have information on age, we can predict the average glucose level of an individual using a simple linear regression model without adjusting for other variables. We discuss the simplest case where we have only one auxiliary variable, the independent variable and dependent variable. So we start again this strokes data. I have imported the data here, and then we need to some packages like sklearn is used for prediction problem. Most of the machine learning models, uh, sklearn model selection model, and then this library we import the train test split, and from sklearn model we import the linear regression. And if we need, for example, we need to model the categorical variable or multinomial variable, then we go for generalized linear models and other class of models. And then from sklearn metrics, these consist of performance where metrics. We import mean square error and R square. So mean square error is basically the h square deviation of the predicted value observed value. We have observed value in our test set. We first split the data into two categories: test training part and test part. For example, we have 100 observations. We just split 80 observation in training set and 20 observation in test set. And then after running the model on 80 observations, we predict the values for the rest of the 20 observations. And for the 20 observations, we have both values and observed values. And then we can compare the difference between these two values are called residuals. And the sum of residuals, sum of squared residuals, mostly used as a performance measure. And if we divide the sum of squared residuals by the degree of freedom, then we get the mean square error. So let's do this in Python. We have x variable, age, and y variable, average glucose level, and then we are splitting data into x train, x test, y train, and y test. Mostly x train and x test consist of uh, two columns, two or more columns when we have axis, and then but y train and y test usually consist of only a single vector. And then y axis and matrix, you can see the set, and then y and test size is 0.2. It means we are keeping 20% observation in our test set. And random state means we are starting set C as 42 for random number generation. And Then we can run this and then define feature X and Y. So we have already done this. And then create and fit the linear regression model using STK uh, scikit-learn. So from scikit-learn, we run a linear regression and then a model on X train and Y train. Basically, this is the model object from linear regression. This is the class of the model. And then from this model, we fit a regression of dependent variable. And then we can predict the values of Y using X test. Now we are using a new observation, the 20% data, the 20% of the axis, which we did not include in a training set. So basically we want to take uh, is has learned and it is well prepared to predict the new value, some out of sample value and see how the prediction is performed. These are the predicted values of the of y. Third values is usually you can just print the I test. Let's see. So we have these two observations for y training and y test. Now we will go far. We have 120 questions. Now we can find the mean square error. So mean square error basically find the difference between these two vectors and then square and sum for all uh, test observations and then divide by the degree of freedom. Basically the number of test observation minus number of parameters. So then the root mean square error is obtained for uh, just take the square root of the MSC and the R square is again when we get the residual sum of square we can uh, divide it by total variation in our y and then we subtract that ratio from 1 that is called R squared. R squared is basically the proportion of variation independent variable explained a function explained by x is considered as better. For example, if x explains 60% variation in y, then this is considered as a good predictor of y. So we can find two measures using the performance metrics from Skyline square and root mean square and R squared. The metrics we got for and based on these performance metrics we can compare different linear regression models. Uh, a better value of R square is considered as a good model. A smaller value of root mean square error is considered as a good model. So we can models use these performance measures and discuss about multiple linear regression in our next session. Thank you.